Yeah, welcome back to our channel, Automotive, and we have some very interesting topics to cover. Um, we are going to start with air conditioning in cars, and we have a lot to talk about this given the changing weather patterns and what we usually prefer to do in our cars, dealing with the dust, dealing with the myths that come with this this facility. Some people assume if I put this happens. If I don't put this, I am saving, or I am spoiling, or I am inhaling dust. So all those things are going to be tackled because I know many of our viewers are curious about what really happens behind the scenes. Hello and welcome our resident engineer, Mr. Ivan Chibuka. I think you are very well versed to break down this topic in this and condition us to understand it.
Yes, thank you very much, Alan. It's been a while since we last interacted, but we are back today to discuss the more technical topics about cars. Today, I want us to discuss air conditioning. As usual, I'm going to share a short presentation about this. Let me know when you can see it.
Yes, I can see it.
Yeah, automotive air conditioning systems. We shall get straight to business. Yeah, the function of air conditioning in a vehicle is to allow setting of the temperature in the cabin to be controlled to the ideal or most comfortable level, depending on the ambient conditions. Sometimes you don't actually need any air conditioning. Yeah, as long as, for example, the temperature is exactly right, is exactly comfortable for you, you may not need to run air conditioning. In fact, there are many vehicles that don't have air conditioning systems, especially in the temperate climates, because they only get summer like 2 or 3 months out of the year. So they may not exactly need air conditioning, although it's now become very common, even for vehicles in those countries, to have air conditioning as a standard installation. So the system as a whole utilizes standard heating and ventilation components. What I mean by standard heating and ventilation components are the blower that you normally have. Whether or not you are running AC, once you turn the fan on or the blower on, you are going to have some air being blown at you in the cabin. So air conditioning has those plus the important addition of an evaporator and a condenser, as we shall see, which both cools and dehumidifies the air. A lot of you are aware that when you have humidity settling on the windows inside the vehicle, running air conditioning clears those windows of that mist. Air conditioning can be done manually or combined with some form of electronic control. Electronic controls are becoming more common. It used to be quite manual in operation. You just press a switch and have some control, like 3, 4 positions for control of the blower speed. That would be it. So you would switch it on and off. When you felt it's too cold, you'd switch it off. When you felt it's becoming too warm, you'd switch it back on, and so on. These days, you just set the temperature and the electronic control will take over. We shall see about that later in the presentation. The system as a whole can be thought of as a type of refrigerator or heat exchanger. Essentially, what you have in the vehicle is a refrigerator. Air conditioning works exactly like a refrigerator, only it is glorified because it is in a vehicle. So heat is removed from the car interior and dispersed into the outside air. Exactly what refrigerators do. The figure in the next slide, which I will show you, shows the basic principle of an air conditioning or refrigeration system. The basic components are the evaporator, which is usually inside the vehicle, the condenser, which is usually under the hood, outside the cabin. The evaporator is inside the cabin. And the pump or compressor, these words are used interchangeably. The evaporator is situated in the cabin, the condenser outside the cabin, and usually in the airstream. That's why you normally find it right behind, no, right in front of the radiator, actually, not behind the radiator. And the compressor is driven by the engine itself, by some kind of pulley system. In electric cars, it's driven by an electric motor. But for purposes of this discussion, we shall consider internal combustion engines. So it's normally driven by the belt and some pulley. As the compressor operates, it will cause the pressure on its intake side because this compressor sucks in refrigerant, pressurizes it, and spits it out on the other end. So on the intake, it causes, because it is sucking in this refrigerant, that side has low pressure. It causes the pressure on that side to fall. And on the side where it is spitting out the refrigerant, that side naturally would be pressurized. So this will allow the refrigerant in the evaporator to evaporate and it draw heat from the vehicle interior. I'm still going a bit wordy, but in the next slide, you see a schematic of how this works. So please bear with me. The high pressure or output of the pump or compressor is connected to the condenser because that's where the refrigerant is being pushed to the condenser. The pressure causes the refrigerant to condense. When you have mist settling on your window, it means warm, humid air is being cooled. It is warm and it is losing temperature on the glass. That's why you end up with mist. So the same thing is happening here. The refrigerant condenses in the condenser, of course. That's why it's called a condenser. That's giving off heat outside the vehicle as it changes state. The same thing that happens on your glass when you have warm, humid air settling on it. It loses heat, the air loses heat, and the water that was being carried in that air now settles on the glass. That's why your glass becomes misty. So we have the same physical phenomenon going on here. So this is now the schematic of the refrigerant flow of a typical fridge, or most cooling systems are like this, whether it's air conditioning, refrigerator, whatever. So you have, you begin at the top here, you have the evaporator inside the vehicle. It loses heat to the surrounding air inside the vehicle, and that's why the temperature in the vehicle starts to fall down, to reduce, because the refrigerant is getting warmed by the warm air inside the vehicle. Now that warm air in turn is cooled because it loses the heat that it had initially. The air inside the vehicle is cooled, and then the refrigerant takes that heat away from inside the vehicle from the evaporator, via the evaporator, and through a pipe, this low pressure warm refrigerant is sucked by and into the pump or condenser, and the condenser spits it out on the other side at a high pressure, but still hot. It came in warm, compressing it made it even hotter, but now it is released to a condenser outside the vehicle in front of the radiator. This is where the refrigerant now loses the heat that it gained from inside the vehicle. So the condenser will normally be warm because it is losing heat, and then the refrigerant which has now lost heat, is turned into liquid. Remember, it came in into the condenser as a vapor. It leaves the pump as the liquid, but still hot. In the condenser, it remains the liquid, but now loses the heat, and is now pushed toward the evaporator once again. In the evaporator, once it reaches the evaporator, there is a valve that it goes through. Helen, do you remember that effect when you spray yourself with deodorant or perfume? Or if you've been spraying insects with Doom, with insecticide from a pressurized container, do you realize that it feels cold to the touch?
Yes, it
Yeah,
does.
the perfume bottle is warm, but when you spray yourself, the perfume feels as if it is cold. It is because the perfume was under pressure in the bottle at that temperature, but once it got out, it lost pressure, and loss of pressure is accompanied by loss of temperature. That's why that perfume or the contents of a pressurized container feel cold when they are released into a lower pressure environment. So the same thing happens here in the evaporator inside the vehicle. So that's how you get the phenomenon of cooling from the air conditioning or refrigeration system. That's how it works in short. So I am going to get a little bit more wordy. Again, you bear with me, but this is to explain the previous schematic. Yeah, so operation of the system is continuous. Like I showed you in the schematic, the refrigerant goes round and round and round until the system is switched off, until the compressor is switched off. So all it does is just go in a cycle back and forth. Yeah, so the compressor pushes low pressure but heat-laden vapor from the evaporator, which is inside the vehicle, and it pumps it as a superheated vapor under high pressure to the condenser. The temperature of the refrigerant at this stage is much higher than the outside air temperature. I described this earlier. Hence, it gives up its heat via the fins of the condenser as it changes state back into a liquid. This high pressure liquid is then passed to the receiver dryer where any vapor which has not yet turned back to a liquid is stored. And the desiccant, a bag which there is a bag they put which removes any moisture or water that is contaminating the refrigerant. A desiccant is a material which absorbs water. You probably come across these desiccants when you get a bag, rather a box. When you go to a shop, Alan, and you buy electronics or you buy shoes, usually you see a small sachet inside that box. It feels like there are pellets that are in the shape of rice inside. Those pellets absorb moisture. So those pellets are made of desiccant material which absorbs any moisture. So they install these bags in air conditioning systems as well to remove any moisture that may be trapped with the refrigerant because moisture is a killer for air conditioning equipment. The pipes and the pumps and everything, it corrodes it and it will rust and all that. So it is important to remove moisture. And also remember, every time your air conditioning breaks down because you've had a leak, your air conditioning technician should first remove any moisture that entered the system because once you have a leak, moisture has access to the internal piping of the air conditioning. Most of you, when you go to the garages, you just request for a refrigerant refill and you keep getting problems like this. In fact, you may have a refrigerant refill. A month later, the whole system or the condenser breaks down because moisture was not removed. I deviated a little there, but I had to caution people about this because it's one of the biggest costs that they encounter with air conditioning systems. Moisture is the biggest killer of compressors or pumps. Not that. If you find yourself buying too many pumps regularly, find out what your technician is doing while they are fixing the system. They could be causing the problem. The high pressure liquid is now passed through the thermostatic expansion valve. And this expansion valve does that effect of the one I mentioned about when I talked about spraying yourself with perfume. So the expansion valve does this job, and the refrigerant is converted back to a low pressure liquid as it passes through a restriction in the valve into the evaporator. Yeah. This element of the system controls the refrigerant flow and hence the amount of cooling provided. As the liquid changes state to gas in the evaporator, it takes up heat from its surroundings. So the refrigerant keeps changing between liquid and gas. Liquid gas is just in a cycle. But every time, basically, the short of it all is this. Every time the refrigerant changes from liquid to gas, you get the cooling effect inside the car. Every time it changes from gas back into liquid, you get the loss of heat outside the car in the condenser. So this cools or unheats the air that is forced over the fins by the blower, which you have running inside. That's why whenever you run air, you switch on the air conditioning, the blower is going to run automatically. The low pressure vapor leaves the evaporator, returning to the pump, thus completing the cycle. If the temperature of the refrigerant increases beyond certain limits, condenser cooling fans outside the vehicle, these fans are usually the same as the cooling fans for the radiator. They can be switched on to supplement the ram air effect. If you are driving at a high speed, the fans may not need to come on. You know, the system will make a determination of that depending on the temperature outside the vehicle. Sometimes the fans turn on, sometimes not. In our environment in Uganda, because our country is warm, usually the fan will turn on the moment you switch on the air conditioning, even when the system is still cold. So, yeah, so a safety switch is fitted in the high pressure side of most systems, and it is often known as a high stroke low pressure switch. As it will switch off when it will switch off the compressor when the pressure is too high due to a component fault, or if the pressure is too low due to leakage, that's protecting the compressor. That's why when you have a refrigerant leakage and the pressure in the system goes low, you turn on air conditioning and it will not work. The compressor will not run because the pressure switch has activated the safety mechanism to protect the compressor. Because if you run the compressor without refrigerant works also as the if you run the compressor without refrigerant, the compressor is going to break. If you run the compressor without refrigerant, the components are going to, there's going to be a lot of friction. So the refrigerant plus some little oil, they add some little oil to the refrigerant, they lubricate the internal components of the compressor. So when it detects that the pressure is too low, as in when you have a leak, the compressor will not run because of that switch coming into play. You have an image now of some of the components that come with this air conditioning system, a typical air conditioning system. Up top on the left, you have the blower motor, and then you have a condenser outside, that's usually outside behind the radiator. That's in the middle on top. On the right on top, you have the compressor or pump. And then bottom left, you have the evaporator. And then you have that expansion valve that we talked about in the middle of the bottom row. And then finally, you have the filter dryer. which you typically have the desiccant. You also have automatic temperature control on most of the newer cars. Full temperature control systems provide a comfortable interior temperature in line with the passenger controlled input. The ECU has full control of, of the fan, the air distribution, the air temperature, fresh or saturated air, and the air conditioning pump or the compressor. I use the terms pump and compressor interchangeably, but they mean the same thing. A number of sensors are used to provide input to the ECU, that is the electronic control unit for the air conditioning. Ambient temperature sensor. So some of the sensors or the inputs into the ECU are the ambient temperature sensor, which is mounted outside the vehicle, usually in front of the radiator or in the grille, to allow compensation for extreme temperature variation. Then you also have the solar light sensor mounted, usually on the fascia panel on top of the dashboard, which allows a measurement of direct sunlight from which the ECU can determine whether to increase air to the face vents. The in-car temperature sensors also allow for accurate cabin temperature reading. Then you also have a coolant temperature sensor, which is used in the system to monitor the temperature of the coolant supplied to the heater matrix. This sensor is used to prevent opening of the system, that is the heating system. Remember, sometimes you need, in cold climates, you need to be warming the air inside the cabin, not to cool it. Yeah, so it is used to prevent opening of the system, of the coolant saturated system, until the coolant temperature is high enough to heat the vehicle interior. And then you have inputs from the driver control switches, which you have on the dashboard, which you touch to control the air conditioning system. So the ECU takes information from all of the above sources and will set the system in the most appropriate manner as determined by the software. Control of the flaps can be either by solenoid controlled vacuum actuators or by small motors. The main blower is controlled by a heavy-duty power transistor and is constantly variable. So that's why these days those interfaces on the dashboard come with a dial, not just switches for different levels. It comes with a dial. You can keep increasing or decreasing the fan speed. Yeah, so thank you for your interest and sticking through to the end. Your questions and comments are welcome. I have a feeling that Alan went offline for some reason. Let me see if we can get him back. So we'll continue. Okay. Yes, Alan, we can go ahead with any questions or comments you have on our presentation.
Yeah, thank you for that presentation. The questions, of course, would be the common ones that fly around. Most people worry that if they switch on the AC, it is consuming their fuel. Others worry that if they switch it on with the windows down, it is not working or it is going to consume more fuel. You know, people tend to worry about anything that consumes fuel. Others also worry when they switch it on or open the vents and then dust is what comes out, even the environment in which we live. Then there's the other one, but that one is more common in hotels where people now start shivering and say, hey, you remove, we are freezing.
Okay.
It's not so common in the cars because I think the temperatures are not that extreme.
Yeah,
but
in hotels where you have air conditioning, which it has happened to me, especially in the Middle East, those guys, I think, put their air conditioning on full blast, Some of the hotels you don't even have, you look for the switch for controlling the temperature. You can't find it, but you can find one for switching it on or off. The newer ones now have remote controls where you can even control the temperature. But if you've been to terminals like in Dubai or Doha at night, these guys, I think it is very hot during the day, so they put the air conditioning on max and they don't touch it for the whole season. So at night it becomes extremely cold, especially if you have a layover where you can't even get out of the airport. It's too short for you to get out, but again, long enough to make you shiver if you are going to be in the terminal for 4 hours and you are not planned. You are thinking, I'm going to the Middle East, it's going to be warm, and you do not carry warm clothing. It can get you. So going back to the air conditioning in vehicles, does it consume fuel? Certainly. Why? It will consume a little bit more fuel than normally because your engine, when it runs, when the air conditioning runs, the compressor is an extra load on the engine. It sucks a little bit more power. It takes away a little bit more power. The engine has to work a little bit harder to keep driving you and also to keep air conditioning running. So it will consume a little bit more, maybe 5 to 10 or maybe 15% extra fuel. Yeah, there's always going to be a cost for everything, especially anything to do with comfort. There's always a cost. If you didn't know, the same thing applies when you are driving at night and you turn on all your headlights, especially if they are full beam. Yeah, you are sucking more power again from the engine through the alternator. The alternator is having to work harder and therefore it loads the engine a little bit more. You consume a little bit more power. It's like the difference between you wearing slippers and also wearing heavy boots when you're walking. Obviously, it's going to cost you a little bit more in energy to walk with the heavy boots. Yeah, so there's an element of that. But because most times when you are running air conditioning, you have to turn the windows up and close the windows in short. That means you are removing a lot of the air resistance that would happen. You see, when you have the windows down, the wind tries to rush into the vehicle, and that creates resistance to the movement of the vehicle. When you roll the windows up, that resistance goes away. Yeah, so now you have this effect of when you drive with the windows up, you have less air resistance, so the engine works a little bit less harder. So when you are running air conditioning, you are trading off the comfort of driving in a hot environment while you are cool inside the vehicle. You are trading that off with, okay, you are losing some fuel that way, but then again, because you have the windows up, you are saving some fuel. So the net effect may be closer to zero in terms of increase in fuel consumption than you think. It depends also on the size of the engine. Small engines have to work much harder, especially going uphill and when driving at higher speeds. So when you load them with air conditioning, they have to work even harder. They scream and all that. While bigger engines take it in stride, they don't lose. There isn't as much difference in fuel consumption, especially with bigger engines, as there is with the smaller engines. If you have a parcel with 1 liter or 800 cc, yeah, definitely you are going to feel a difference when you drive with air conditioning, especially if you are driving in hilly areas. But somebody driving an SUV with a 4-liter engine, I doubt it will make much difference in my experience. I've driven diesels for the last about 16 years. A diesel that is bigger than 2 liters, 2.5 liters, usually I can't tell the difference in fuel consumption. If I drive with air conditioning running from Kampala to Arua, and I drive back from Arua to Kampala without air conditioning, if you ask me, I never noticed any difference in fuel consumption. Yeah, as regards the dust inside the vehicles, yeah, that can happen, especially if you've been driving the vehicle with open windows, you're not running the AC, and over time you've been driving with open windows in a dust environment. That dust comes from outside, comes in through the windows, settles on the vents or everything inside the vehicle. So the moment you turn on the air conditioning, when you turn on the blowers, when the blowers turn on, you are going to blow that dust right back to you. So if it's dust that came from outside the vehicle, unless of course you are running the air conditioning system or the blower in that mode where it brings in air from outside into the vent, because there are two modes. There is one for bringing in air from outside to displace the air inside, so that you get fresh air from outside. And then there's also the desaturation mode. So if you're not in the saturation mode and you're pulling in air from outside and your filter is bad, because usually there's a paper filter in the system, in the vents, that block dust. So if that filter is bad or it is removed and there's dust outside, you're definitely going to get the dust inside the vehicle as well. Yeah, so if it's not that, if it is just dust that had settled within the vents, it will be temporary. When you turn on the AC or the blower at high speed, the dust will come back at you from inside the vents, but pretty soon, within a minute, it should stop blowing dust. Whatever dust that has been blown at you will settle, and then the system will continue with cleaner air. Naturally, there is always going to be dust settling in the vents in our environments. We've run out of time. Allow me, Alan has gone offline again for some reason. Yeah, allow me to end this session here. We shall meet again soon. We shall be discussing multiplexing systems in vehicles. Thank you very much once again for your time listening to us. And oh, Alan is back. Alan, are you back? Alan, sorry. I think we are having internet issues, but you found me winding up. I had responded to your comments or questions regarding the air conditioning that you had. Yeah. Unfortunately, we've run out of time. We have only like 1 minute left. I was telling our viewers that we shall come back to discuss multiplex communication systems in vehicles. Yeah, I'll leave you to bid our viewers bye-bye.
Okay, thank you very much for the explanations, and I hope our viewers' fears have been put to rest. And we look forward to learning more and more about our cars and these systems that seem complicated. Thank you.
Thank you very much.
Stay tuned.
Yeah.